In this video, I'm going to talk a little bit about net present value profiles and how they relate to rankings of projects. The basic idea behind a net present value profile is that it shows the different net present values that would arise for a project if different required rates of return are used in the net present value calculation. So for instance, if you're calculating net present value, you have to specify a discount rate or a required rate of return. So perhaps you could have a required rate of return of 10%. The idea behind the net present value profile would be, well, instead of just trying at 10%, what if we showed the net present value using 8%, 12%, 16%, and so forth. And for each of those different required rates of return, a different net present value would arise from that net present value calculation. The net present value profile basically then just shows the net present values that arise for each of those different particular required rates of return. And you can then see how the net present value is being affected with the use of different discount rates. Now, if you're showing the net present value that arises for different required rates of return, it's important to note that if the required rate of return that makes the net present value exactly equal to 0 would then be the internal rate of return. Because by definition, the internal rate of return is the discount rate that makes the net present value equal to 0. So if you plot the net present values that arise from the different required rates of return, the spot where you see that net present value line cross the 0 value, that spot on the x-axis, the required rate of return, that's going to be the internal rate of return for the project. Now, that means that the graph would look something kind of a little bit like this. So basically, if I had two projects, projects A and B, so basically all I'm doing is calculating the net present value for these projects using different required rates of return. So if I had a required rate of return of 12%, project A would have a net present value here, project B would be a little bit higher. If I had a required rate of return of 26%, project A would be negative, project B would be even worse, right? So the net present value profile is just showing what that net present value is for the different required rates of return. Now, it is worth noting then that there's something called a crossover rate, and that is going to be a rate of return in which the net present values for two projects are equivalent. And we may or may not care about this rate. I'll talk about that more in a moment. But on the graph that I have here, this spot right here, where those net present value profiles cross, that's going to be our crossover rate. And so it looks like it's a little over, probably on this graph, probably a little over 14%. And basically at that discount rate, both projects have the equivalent net present value. All right, now let's talk about independent projects and mutually exclusive projects. So if you have multiple projects, let's say we just have two projects. You have two projects that are available. So two different things you could do with your money as a company. So maybe you could buy a new piece of machinery, or you could invest in something that's going to save you some money in another part of your facility. So if you have projects that are independent, what that means is those projects do not affect each other in any sense. And so what that would mean then is anything that looks attractive, we are going to accept and going to proceed with. So basically for independent projects, my selection of one project does not affect my selection of the other projects. I could select the first project, I could select the second project, I could do both projects, or I could do neither project. So my selection of one is independent from my selection of the other. If projects are mutually exclusive, that means that they are related in some way such that accepting one project requires rejecting the other project or projects. And so to give you a sort of example, let's suppose that, and this is more of a personal example, not a capital budgeting example per se. Well, let's suppose that there was a theatrical production on a particular evening as well as a concert. And let's suppose that you wanted to go to both. Well, if both of those things, that theatrical production and the concert, are at the same point in time, they are mutually exclusive. You cannot attend both. You could attend either the theatrical production or you could attend the concert, but you can't do both because it's not possible to be in two places at once. So in that case, that would be a mutually exclusive arrangement. On the other hand, what if the theatrical production and the concert are at different times, or perhaps on different days and different times? Well, if they're on different days, then attending one does not necessarily automatically preclude attending the other. However, there are some other reasons in which in this example, the two different things could be mutually exclusive. For instance, suppose you only have enough money for one ticket. So if you only have enough money for one ticket, well, in that case, you could either go to the theatrical production or you can go to the concert, but you can't do both again. So even if there's not a time conflict, they could still wind up being mutually exclusive, perhaps from a financial standpoint. You just don't have enough money to do both. So when I say projects are independent, it truly means if I select one, it doesn't have any bearing on the other. So in the example, that would be a situation in which I'm looking at a theatrical production, I'm looking at a concert. They're not at conflicting times. I've got enough money for both. There's no reason I can't do both. And so if that's the case, then my choices for those independent projects are basically I can go to the theatrical production, I could go to the concert, I can go to both the theatrical production and the concert, or I could do neither. So those would be my choices if the projects or if those choices are independent. And that's the same idea behind a capital budgeting project. So if I've got multiple capital budgeting projects, if they're independent, what it means is I could select one of them, I could select the other one of them, I could do both of them, I could do neither. The choice really doesn't affect the other projects. So for each particular project, my choice does not affect the others. So basically, I'm just going to select or choose to do any project that's going to increase shareholder wealth. So anything and everything that increases shareholder wealth, we're going to do for independent projects. For mutually exclusive projects, it's actually not so much about whether or not I think a particular project is attractive. It's about how does it look relative to the alternative. So going back to that example of the theatrical production and the concert. Well, if you evaluate those two options, if you really want to go to the concert more beneficial in the sense that you want it more, you like it more, you're going to enjoy it more. Well, if they are mutually exclusive, the fact that you like that one better means you reject the going to the theatrical production. So for mutually exclusive projects, it's all about sort of the relative valuations of those projects. So if I have two different capital budgeting projects to choose from, and they are mutually exclusive, I can't do both. So what I'm going to do at that point is I'm going to try to pick the project that's better, because my picking that project that's better automatically involves rejecting everything else because they're mutually exclusive. Now, if the projects are mutually exclusive, whether that's due to there's limited amount of room on your factory floor, you have limited amount of financial resources, or some other reason. So if they are mutually exclusive for whatever reason, and I have to pick one, let's talk about one of the implications of that. You can actually have a situation in which there's a conflict between what the IRR is telling you to do and what the net present value is telling you to do. So let's take a look at that net present value profile again to see that. So if I'm looking at this net present value profile for these two projects, so project A and project B. So if I look at this, project A would have an IRR here, because this is the required rate of return or cost of capital that applies to the project, at which net present value is 0. So project A would have an IRR here, project B would have an IRR here. So project A clearly has the higher IRR, which means it looks like project A is producing a higher rate of return. Now, which project has the higher net present value, however, depends upon which cost of capital we're using. So at a cost of capital of 10%, project B has the higher net present value, and project A has the lower net present value. At a cost of capital of 16%, project A has the higher net present value, and project B has the lower net present value. So which one looks better from a net present value standpoint actually depends on what the cost of capital is. So let's say that our appropriate risk-adjusted cost of capital or discount rate is 10%. According to net present value, it's saying B looks better. However, A has the higher IRR. So A is expected to generate a higher rate of return. B has the higher net present value. What do we do, and what's causing this? What's causing this is basically project size or timing differences. So in other words, one project may cost more to do than the other. So that's the project size issue. The timing difference is a little bit more subtle. So notice on this graph, time is not on either axis, right? We have cost of capital that's applicable to the project on the x-axis. We have net present value on the y-axis. There's no time listed on this graph. However, the timing of the cash flows for the different projects actually does matter. So let me give you an example for that. Imagine I had two projects. One project, you invest money today and you get a cash flow in 1 year, and that's it, end of the project. So let's say that's project 1. Project 2, you invest money today you get no other cash flows for 10 years. You get one big lump sum at the end of 10 years. And that's it. Okay. Well, if I'm looking at those two projects and I start changing the discount rate, those two projects are going to be affected very differently. So the first project, because it only has one cash flow at the end of the first year, if I increase the discount rate, it will be affected. So the net present value will change. However, it only has one cash flow. It's only 1 year in the future. So even though it's affected by the increase in the discount rate, it's not going to be affected drastically. On the other hand, the second project had one cash flow that happened in 10 years. Well, if I'm thinking about a cash flow that's happening in 10 years, when I try to find the present value of that cash flow, that involves 10 years worth of discounting, which means a small little change in that discount rate can have a disproportionately large effect on the present value, which basically means if I'm looking at two projects, the farther out into the future, relatively speaking, those cash flows are, the more the net present value will be affected by an increase in the interest rate. So if I'm looking at this graph, note that project B, for a given increase in the discount rate or interest rate, project B's net present value drops faster. In other words, it's got the steeper slope. So project size differences and project timing differences, so the timing of the underlying cash flows, can change how the projects respond to different cost of capital figures. And that's what can create a situation in which, well, if the cost of capital was 10%, project B looks better, but project A has the higher IRR. So that's ultimately what can cause that conflict between the internal rate of return and the net present value. It's basically a size or timing issues associated with the project. Now, if you have a conflict like that, where you're looking at a situation and let's say the required rate of return or applicable cost of capital is 10%, and net present value says B, but the IRR says A, what do? Well, let's kind of review for a moment. Net present value assumes that when you get a cash flow, you reinvest it at the normal required rate of return. The internal rate of return, however, assumes that when you get a cash flow, you reinvest it in an identical project just like this one, which is probably not as good of an assumption. I probably don't have an identical project just lying around. So because of that, when a project looks good, the IRR assumes you reinvest in another really good-looking project. And when a project looks bad, the IRR assumes you reinvest in another equally bad project, which basically means the IRR will overestimate in both directions. So something is good looks extra good based on the IRR. Something is bad looks a little extra bad based on the IRR. So if I'm faced with a conflict where IRR appears to be pointing me in one direction, net present value is pointing me a different direction, side with net present value in that case, basically because it's based on a better set of assumptions. Okay. So overall, if I'm looking at net present value profiles and rankings, some points to remember. Make sure that if I plot the net present value at different required rates of return, that line should cross zero net present value at the IRR as the discount rate. So that needs to happen. If they're independent, I can plot both of them on the graph, but ultimately I'm just going to pick out anything and everything that is going to produce a positive net present value for a given required rate of return. So I don't really have to compare projects if they're independent. For mutually exclusive, it's all about picking the better project or the best projects if you have multiple ones. And that's kind of the idea behind doing the net present value profiles and rankings. There is another benefit to doing a net present value profile as well, and that is if a project had multiple IRRs, and I've referenced that in a prior video, if a project had multiple IRRs, which would only arise if the future cash flows have at least there's some negative future cash flow in there, then if I do a net present value profile, what would happen is I would get some kind of a U shape on there, possibly a U shape like this, okay? Probably more like this in a limited sense there, because generally the higher the net present value gets, generally the lower it's going to make the net present value. But basically, if I had some negative future cash flows, there's the potential for more than one IRR, and I could have a U shape. And that's where doing that net present value profile can be handy. Calculate net present value for multiple different required rates of return, put it on a graph, and kind of see, do I have multiple points in which that net present value line is crossing that x-axis? Because if I have multiple points where it's crossing the x-axis, that means there's more than one IRR number. The reason why that's important is Excel does not tell you there's more than one IRR number when you ask it to calculate the IRR. All it does is it looks to find a discount rate at which the net present value is 0. And when it finds one, it says, hey, there we go, here's the number. It's not going to tell you, oh, by the way, there may actually be other ones that are out there. So if you actually had a situation where a project had multiple IRRs, when you calculate the IRR in Excel, you can tell Excel where to start guessing values. And if you do that, you might be able to get it to actually tell you both of those two different IRR values by telling it where to start guessing at different points. But at the end of the day, ultimately, it would just be helpful to be able to do a net present value profile to kind of check for that multiple IRR sort of scenario. All right, hopefully this video has been helpful. Thank you so much for watching and have a great day.